Alright, so for the last day of the week, we're going to look a little bit at these transformations of these trig functions, so the translating the trig functions. I asked you guys to make your predictions. I asked you guys to make your predictions for these three, right? Or at least these two, cosine and sine, and then tangent. Now, we also are going to use the transformations to find the period, amplitude, and midline. But hopefully you just see the transformations first of all. We have four, yep. We have A. I want to know what happens if I multiply A. B. I want to know what happens if I multiply B on the inside. H and K. And we could call them A, B, C, D, but we'd see H and K more often. So we'll start with the sine function. They all kind of act the same. So sine, cosine, tangent, they all kind of act the same. Well, tangent is a very different graph, but we're just going to look at sine for this one, cosine for this one, right? It's just easier to do it that way than to do all sine, all cosine, all tangent. So we'll do one at a time-ish, incorporate them. All right, so let's start here. Sine x, I want to graph two things. I want to graph sine of x, and I want to graph sine of x plus 3. Now notice where that plus 3 is on the outside of the parentheses. So if I'm doing on the outside of parentheses, I'm looking at k. All right, looking at k. So that's what we're going to figure out. What does this graph look like? All right, so we should probably graph one at a time. If you go to your calculator, I can go to y equals and do sine of x and hit graph, and you can see that it looks like this. Obviously, it is not perfect because my axis up here is numbers, my horizontal axis is numbers, whereas here you're talking about numbers on the vertical, radians on the horizontal. So we gotta be careful a little bit. Here's what I will say though, just for the sake of time. The sine of 0 is 0. Okay. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. Sine of negative pi over 2 is negative, I said 1 and then I wrote 2. That should go there. That should go there. Negative pi would be 0. So you can kind of see how this is going to look. It's going to look something like this. Okay. Again, just a rough sketch, but we can fill in this table too. So sine of negative pi is 0. Sine of pi is 0. Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. Okay, so we have all these points. Now, let's look at sine of x plus 3. So we have this plus 3 on the outside. If I was to graph that, sine of x plus 3, just to look at the graph. Oh, hang on. Hang on. I didn't close my parentheses. Plus 3. Alright, so maybe you see a difference here. To me, it looks like it moved up, but I want to know specifically where that's at. So let me just look at some points here. So let's go quit. We'll go sine of pi plus 3. It's 3. So sine of pi plus 3. So when I plugged in pi, I got 3. Sine of 0 plus 3. Get 3. So for 0, I got 3. Sine of negative pi. plus 3. So it should be sine of negative pi plus 3. I get 3. And then 2 pi, we can assume it's going to be 3 as well. Alright, so let me graph this with negative. We have 3 right here. 0, we have 3 right here. 2 pi is 3. Here's what this graph looks like. Alright, so it's the same exact graph. You can tell it's just the same exact graph, but it's just moved up. You know, it's not at 0 anymore, it's at 3. So what can we say about k? When I added k there at the 3 on the end, when I add or subtract k, graph translates up or down k units. Okay, translates up or down k units. So in this case, we have plus 3 on the outside. What happens? I move up 3. Okay, so that's what happens when I fool with k there. All right, when I fool with h, right? Because remember, look at k is on the outside, h is on the inside. So k we just did in red. H we'll do in, I don't know, we can do it in yellow, I guess. H is on the inside, so subtracting h on the inside, let's see what happens. We're going to look at the cosine function this time. So, again, their behavior is very similar. It's just, you know, we're incorporating sine and cosine interchangeably here. So, cosine of x. Let's look at our graph for cosine of x. You can tell that it's very similar to the sine function. The biggest difference is right here. Okay, my starting point is different. Instead of 0, 0, I'm now at 0, 1. So cosine, again we'll do cosine in x in blue, cosine of x plus pi over 2 in green. Okay, so we said that cosine of 0 is 1. As this turns out, cosine of pi is 1. Cosine of pi is 1. Cosine of 2 pi is 1. Cosine of pi over 2 is, excuse me, cosine of negative pi. Sorry, my pen was not being cooperative there, so I was a little distracted. Cosine of negative pi is negative 1. Cosine of 0 is 1. Cosine of pi is negative 1. Okay, so you alternate negative 1, 1, negative 1, 1. So negative pi would be negative 1. 0 would be 1. Pi would be negative 1. 2 pi would be 1. Okay, here's what that graph looks like. Again, I'm just doing a rough sketch here. A very rough sketch. Let me try that again. Okay, so you can see that it has the same kind of shape as up here. It just has a different starting point. So it's almost like translated left to right, but that's for a different time. All right, so cosine of x plus pi over 2 on the inside. Let's look at this. So we're going to do cosine of we'll start with negative pi. Cosine negative pi plus pi over 2. You get 0. Okay, so cosine of negative pi plus pi over 2, you get 0. About cosine of 0 plus pi over 2 on the inside. So what you're doing is cosine of 0 plus pi over 2. You get 0. And then we can assume, I'm assuming a lot, but I can assume that the other two are going to be that way too. Okay, let me graph this. Okay. This graph is a little bit tricky to see, but if I go to my calculator, let me graph cosine of x plus pi over 2. Okay, the blue one's cosine of x, the red one is cosine of pi over 2. You can tell that they're kind of intertwined. It's kind of a weird looking graph. They're kind of intertwined. This point right here, I think you guys can see the cursor. This point right here is now shifted left here. This point down here shifted left here. Alright, so if I'm shifting left, what's really happening is, okay, so we said this point is shifting here, this point is shifting there, so what you actually get is the precision here. And then that one. Okay, so what happens? This moves, this bottom one moves, this top one moves, and they're all moving left pi over 2 units, which is like, I mean, here's this 0 to negative pi over 2, well, that's pi over 2, right? Pi to pi over 2, that's pi over 2, right? So what's happening is we're moving left pi over 2 units. So what happens when you add or subtract h to the outside of the equation? Remember, this is h right here. H, subtract h. You translate left or right h units. Very, very important. Notice that this is plus pi over 2, but I move to the left pi over 2. So as I always say, think opposites. Okay? You gotta think opposite. If you can think opposite here, so I have plus pi over 2, I'm moving to the left pi over 2, that's gonna make your life a lot easier. So again, you are moving to the left or right, h units, depending on whatever that h is, inside of your parentheses. Okay, that's going to be the end of this first video. I'm going to make a second video when we multiply on the outside here.